All right, so here we are. We're ready for another lesson. This is March 21st, 2020. March 21st, 2020. Today we're going to do another lesson on probability of independent events, but we're going to use fractions. Probability using fractions. So we're going to do a couple of things we haven't done here before. So I've got the blue die, and it's numbered 1 to 6, and I've got the red die, which is also numbered 1 to 6. So we're going to use these as our options. Keep these out over here. So we'll do this through examples again. And let's say that you have example 1, and we want to say, suppose a die with 6 sides and another die with 6 sides are both rolled. Okay, so that's going to be our situation. We're going to see what is the probability, what is of rolling blue and 4. So this is a kind of an interesting one, a bit of a different situation. We haven't looked at something like this yet, and the way we would look for that is probability blue 4. Now in the first situation, with the first die, there are 6 possibilities, but there's only one color possibility, and that's blue. And there is the red die, which isn't in play right now, but the numbers are in play. And the way that we figure this out using fractions is by creating a fraction for each one of the events and then multiplying it with the other event or events, because this could be used with more than 2 events as well, which we'll do an example of some other time. So the probability of rolling blue, the probability of blue by itself is 1 out of 1, or just 1. That's the only possible color you can get. And the probability of rolling 4 on the red die is 1 out of 6 possible numbers, because that's how many possible outcomes there are, and the 4 is just one of them. So to find this solution, we take the first fraction and multiply it by the second fraction, so we find that the probability of blue 4 is equal to 1 out of 6. Let's use the same situation where we have now the numbers only. So what is the probability of rolling an even number and a 5 on the second die? Well, the probability of even is 3 out of 6 possible ones. There could be a 2, there could be a 4, or there could be a 6. And the probability of a 5 is 1 out of 6 possibilities, 1 out of 6 possibilities. So we put that knowledge together of each event, the even independent event multiplied by the probability of rolling 5, and that ends up being 3 times 1 is 3, 6 times 6 is 36. That would be a good enough solution, so the probability of even and 5 is equal to 3 out of 36. You always want to ask, can you simplify that? And of course 3 goes into itself once, and 3 goes into 36 12 times. So you could also create that as 1 and 12.